I'm sure you've seen headlines like this in the past about the data being fuel of the 21st century. But to be honest, businesses have always relied on data to make important decisions, to delight their customers, to improve their financial efficiency. If you're working with the data, if you're a startup CTO, data engineer, you may expect your business to come to you and ask you questions like what signals our customers are sending us, which services we should actually include, which features should we actually fade out, if we're planning to expand, to which region, to which geography. So to answer those questions, you actually need data. My name is Ermin, and I'm a senior solutions architect. I work primarily with startups and with SaaS company. And today I will be talking to you about modern data architecture with a focus on SaaS providers, or how I like to say, all the things that will actually go wrong in your data analytics journey. I've split our today's presentation into 4 main parts. First, let's talk about the problem, right? We will define a problem statement. And this is actually what I've seen with my customers and what I also did in my career. So this is a typical data analytics journey that we have. Second, we will go to a solution, and I will present how a solution may look like for you. And on the third side, on the third part, we will actually then talk about how the implementation of modern data architecture could look like on AWS and how AWS can help you to implement it very fast. And then we will go back to that SaaS lens, and we will be talking about data isolation. We will be talking about deployment models for SaaS and how that helps us, how that reflects on the modern data architecture. So let's start. So how do we usually start with the data? Usually when you actually work with the data, you start with your operational system. Right? You have your database, you have your backend. Backend is producing some log files, emails, database is storing data, all fine. And then you have your manager comes to you and say, look, Ermin, I need to get a list of all transactions across the last 3 years, broken by geography and user type and what else. So you say, well, easy, I can do that, right? So what you do is you then go and query your raw data. You query your operational data source. So you, by querying raw data, you transform your data into insights. And it's easy, it works, you can actually deliver it very quickly, and you keep building reports and you keep building extracts and analytics based on your operational data sources. And it works until it doesn't. Why? What happens? If you're a successful startup or if you're a successful business, your business starts actually growing. It starts actually accelerating. You start getting new types of customers. And even in SaaS companies, within your B2B customer, you may have different personas to serve. You may have also different personas internally to serve, from marketing, accounting, sales. So that actually increases complexity, and it leads also to the data explosion. Now, suddenly your easy and system that looks like this turns into something like this. You have different data sources to query from, especially in SaaS. You have different backends, different databases. So you start actually building your queries, and then you start having what I call little fires everywhere. So how that actually affects our customers? Well, first of all, relational databases, they're hard to scale. So usually how you scale relational databases is to throw more money on it, get a bigger instances, more CPU, more RAM, more storage. Durability gets also impacted because, bigger backups, longer restore times. Even more important, complexity of your queries gets actually bigger, right? So by bigger complexity, you actually have a smaller agility, and performance actually gets impacted. Cost goes up also for your customers. Quality of your delivery goes down, and latest then your customers get impacted. And when your customers get impacted, you have the real problem. Now, what we say is, okay, let's rethink everything, right? So let's pull back and see what do we actually need. On the left side, we have our raw data, and on the right side, actually, what we need, what our business, what our customers need from us are actually insights, not the data. So you think, okay, if I would get the raw data and extract it from my raw data source, relational database, for example, and transform it, mold it into a new format, and then load it into a new storage, I can actually quicker and better get those insights. So we actually define something which is called ETL, extracting, transforming, loading. And this now looks like this. Let's call that a data pool. I have my different data sources. It could be my databases, it could be my IoT devices, it could be my logs. I'm gonna extract, transform, and load this data into something which is called data warehouse, or in this case I built a schema which is a star schema, so that I can actually quicker query those data. So, and everyone is happy. My users now have exactly dimensions that they need. They have exactly data that they need in one single data source. I can build my query very quickly. Agility is back and everyone is happy, right? Well, it works until it doesn't. So it happens again, right? So your business actually starts growing. Number of personas that you're serving starts increasing. So every persona type that you're serving needs a little bit different shape and look, so facet on the data that you have. And then, explosion of the data again happens. So what happens is actually your standard ETL process, your simple little data pool that you had before starts getting more complex because you build new data marts and building new kind of data warehouse schemas in place. You have different personas that need to query data from different data sources again, and then again you start actually having little fires everywhere. Your queries are more complex. Your users are actually your users get their results slower. Even more important, your ETL process get actually more complex. So you need to get your best engineers to tailor that ETL process, to monitor, to make sure that it actually works. And then your data source also gets impacted because of that ETL process is querying that data constantly. Now you have, again, across all those dimensions, you start having issues with scalability, complexity of the queries goes up, performance goes down, cost increases, and then quality goes down. At the end, customers get impacted, and we're back to the square one. We have exactly the same problem as before. So let's now look how we can solve this. What we actually need is just a centralized repository where we can store all our data, structured or unstructured data, at any scale. So something that is robust and it can actually grow with our needs. And that's why we have customers now that are moving from this silo approach of building data mart per persona or data warehouse per persona into something like this. And this on the right side, this is actually what we call modern data architecture. So modern data architecture is relying on 4 pillars. So it's being defined by 4 pillars. What are those? First, we need storage. So we need a place to store all this data. Second, even if you store the data, you need services to be able to consume those data and then to create value for your customers out of the data that you stored. You also need something which actually will help you to move the data into your data lake and also out of the data lake, but also between those services on perimeter of your data lake. And fourth pillar is actually governance. So you need a service that will help you to govern your data lake, to make sure that you're compliant, that you're secure, that you have tenancy model in place and data isolation in place and all those things. So what are the benefits of approach like this? I've selected for us for my favorite benefits. And one is, now suddenly we have all data in one place. We don't have data now split across different data sources. We can actually have opportunity to have a simple querying of one data sources instead of going across different data sources. The second is actually storage versus compute. I already said, with the database, you get bigger instance with more storage and more compute and more RAM and things like that. Here you have opportunity to independently scale your storage if you need more, but also independently scale your compute. That means you can scale up when you need more compute power and scale down when you don't need it. So that's actually, and data lake enables you architecture like this. And then one of the things that I already mentioned before, ETL processes can become very complex. With complex ETL processes, you put your most senior engineer to handle those complexity, to observe, to monitor, to fix the issues with the ETL. With this one, you have actually quick ingest and simple way to move the data into the data lake. And then the fourth and my favorite one is actually schema on read. So there are two concepts. One is actually called schema on read and the other one is called schema on write. When you build your data warehouse, you're using schema on write. And schema on write means that you need to know your schema even before you put data into it. How it usually works. You go to your business and say what type of reports you need, and they tell you, the reports. You figure out of the reports what dimensions, so which categories, and which actually transactions do you need facts. So you actually design your data mart, so you define that schema. Now when you define that schema, you will actually now go and develop your ETL process to get the data from the data source, mold it, so transform it, and put it into predefined schema. So you need to have your schema on write. With data lake, you have something which is called schema on read. So that means you can put data into the data lake, and then you can actually create the schema when you need it for new personas that are actually coming into your life. Let's now look at how AWS help us build a modern data architecture and how would actually modern data architecture look on AWS. When we talk about storage, we're talking about Amazon S3, right? Amazon S3 is an object storage with 11 nines durability that can actually grow. I already have customers with exabytes of data, right? That's not uncommon anymore, and they are actually using S3 to store their data. Amazon S3 is one of the first services, so the follow-up services on AWS, they all work very well with Amazon S3. So you can actually use Amazon SageMaker to do the data analytics. You can use EMR to do big data processing. You can actually use OpenSearch to actually do the log analytics. Redshift, your data warehouse, can access that data on S3, can read it, and it can actually, even quickly load it into your data warehouse if you need it. The third pillar is actually seamless data movement. On AWS, the service is called AWS Glue. AWS Glue is a ETL service that will help you quickly move data into the data warehouse, but also, between the services if you need it. And the fourth pillar, data governance. Actually, we call it AWS Lake Formation, and AWS Lake Formation is the service that will help you roll all those components. So quickly build data lake, but also govern that data lake. How would a simplified data architecture look on AWS? And this is actually very simplified. So on left side, you will have your data sources. That could be on-premise data, it could be streams, it could be your databases, it could also be your IoT data or your logs. So you will move the data into an S3. Now, when the data is on S3, you have AWS Glue Data Catalog to build a virtual database with virtual tables that are basically views on your data in the format that you need to actually point on that data on S3. And now when you have it in the AWS Glue Data Catalog, you can use consumer services to query that data. Again, SageMaker, Amazon Redshift Spectrum to query basically data on Data Lake, or QuickSight to build beautiful report, Amazon Athena to ad hoc query data, export it, or to test what you have in the data lake. Right? Those are all the services that you can actually use with your data lake. But it's not only those 4 or 5 services that I mentioned. AWS gives you an ecosystem of services, right? From analytics and data processing up to data governance, data ingestion tools, and things like that. So you actually can use the right service for the job. Now, when we described how the data lake could look like on AWS, let's now put our SaaS provider lens and look how SaaS data architecture looks like. As a SaaS provider, you know that it's extremely important that customer A cannot see data of customer B. So you need to have this data isolation. So how do we do it? As a SaaS provider, you probably know that we have 3 different SaaS deployment models. The first one is silo or share nothing model. So that means that each of your tenants will get dedicated infrastructure, so dedicated web, dedicated backend, and dedicated storage for each of your new tenant. Opposite of that one would be something that we call pool model. And pool deployment model is actually share everything. That means all your tenants will share the same web front end, same backend, and same storage. So all data of your customers will be stored in one single storage or in the shared storage. And then in between, you have something which is called bridge or mix model, which means, for example, like in this diagram, that your tenants are sharing web layer, but backend and storage are isolated per tenant. So let's apply the same model now on our modern data architecture and the way how we store data. When we think about silo would be actually account per tenant. That means that your storage, your AWS Glue data catalog, so your middle layer, and your consumer layer are completely isolated, because they're actually in a separate account. If you get a tenant 2, you will create a new AWS account and do the same deployment, and you will actually keep doing that for every new tenant that you get in your application. So let's look at pro and cons of this approach. Pro is actually that this is actually quite good for a smaller number of tenants. It's also easier to do tenant isolation. Why? Because you rely on the tenant isolation that AWS does for their customers, in this case you. So you have an account created per your tenant. And you can also do encryption per tenant. And don't forget, it's also easier for you to allocate costs per tenant because costs are actually coming per account. On the other side, you have only 10 accounts by default on AWS. So that means if you need to have more than 10 customers, you can actually it's luckily soft quota, you can raise that quota to up to 10,000 customers. What's really important with this one is you need to have automated and bulletproof DevOps processes, observability, what we call actually operational excellence. Your team needs to be on the top of the game. I work with the customers who have 5,000 plus accounts because they work in silo, in a serverless, and that works beautifully for them because they actually have their operational excellence under control. Let's now move to bridge model. For bridge, I prepared 2 different options, right? So the one option is bucket per tenant. Bucket per tenant means that we will use one AWS account, but each tenant will store its data in its own bucket. So the data is actually isolated. We can actually build on top of that isolated AWS Glue data catalog, and they will share the services like AWS Amazon Athena, for example. So what are the pro and cons of this approach? If you look at it, it works also for smaller collection of tenants, right? So where you need 10 to hundreds of tenants, right? So for B2B businesses, that could be enough. For B2C, that could actually be an obstacle. You can have a unique encryption key for each bucket. You can also track costs per tenant by using labeling, right? You can use cost allocation tags to get the cost per tenant. On the other side, you need to consider that which is called bucket quota, and bucket quota means that you get by default 100 S3 buckets you can create up to 100 S3 buckets in one account. you can increase that quota to up to 1,000. But remember, right, each bucket needs to have a globally unique name, and avoid tenant names in a bucket name, because they're actually also visible. You also need to make sure that those S3 accounts are not actually dedicated, S3 buckets are not actually dedicated only to your SaaS application, but you will have probably, raw data bucket, you will have some other bucket, so that quota from 1,000 goes actually, below 1,000 customers that you can serve. Another option could be, for example, right, option 2, that you have table per tenant. So that means you will actually store all your tenants' data into one S3 bucket. You will split it per prefix, and then you will isolate it using AWS Glue Data Catalog and build table per tenant, or database per tenant. And then you will, on consumer side, use again shared services. So in this case, you don't have actually a problem anymore to store limited number of customers. You can actually store unlimited number of objects, unlimited number of customers, and that of tenants. So that actually solves your problem if you're a B2C, for example, business, or if you have more than 1,000 or 10,000 customers. You need to consider that you may not have evenly distributed data on S3, because you may have bigger and smaller customers in the same bucket. You need to track still consumption on S3. You can use Amazon S3 inventory to track the consumption of the services per tenant. And to be honest, bucket policies in that case can become a little bit complicated. Let's look at the pool model now. On pool model is share everything. That means we will have one bucket for all our tenants. We will have one AWS Glue database and tables for all our tenants, and then we will have one consumer services. But then, what we have something which is called AWS Lake Formation, and AWS Lake Formation is that governance service I mentioned before. AWS Lake Formation will enable us to do a tenant isolation and to implement something which is called row-level security. It usually looks like this. You as a user, you actually would like to access your data lake. So how you go to your service. Your service goes to AWS Lake Formation. AWS Lake Formation issues a token to tell you what you can see, and then thanks to that you actually go and query the data, but you get only those data that is being defined by AWS Lake Formation. Let's look how that works. If you go actually on AWS Lake Formation, you can select a principal to which you would like to grant rights. That could be your user, or it could be a role. And then once you do that, you actually can select object on which you would like to grant user rights, like a database table. And then when you define the database table to which these two users have rights, you can actually define which access policy they would have on this particular table. It could be select, update, delete, or things like that. Even more, right? So let's put our SaaS lenses again on. So for SaaS, we need row-level security. So how do we implement that? So Lake Formation gives us possibility to implement column-based security, which means you can actually define for your customers, tenant, or for the users, or for the roles, which columns they can and which columns they cannot see in the table. And you can even define which rows they can see and which rows they cannot see. I will show that in the next slides in a couple of seconds. But if we combine suddenly those two, right, column level isolation and row level security, you will see that you get something which is really powerful, and this is cell level security. So how does that look like? Again, you will actually go and select your principals. Let's say we have a particular users that we would like to grant rights to. You select to which database and which database table the user should actually have rights, And once when you do that, now you can actually go and define the isolation on the column level. In this case, users can see everything except 2 columns, and this is the patient name and patient date of birth, because you would like to protect personal PII, personal identifiable information. And then if you go to the next bit on the slide, you can see that actually this particular user will be able to see all the columns except these 2 mentioned, and also it will be able to see only data from New York City. That means even if I, as a user, issue now select star from a particular table, I will see only data that is actually marked as for New York City. And then once when I have this one, I can again go down and then issue specify. I can now go down and specify which access rights the user will have on those tables. Is it select, update, or delete? And through that, we actually can produce something which is called cell level security. So that's it actually from my side. So let's just recap quickly on what we delivered so far. We said that your OLAP, right, online analytical processing, so your operational system, your data warehouses, and your modern data architecture, those are not actually mutually exclusive concepts. They can actually work together, and you can still actually build. You may still need your data warehouse also, although you have your data lake. You also need to. We also covered how the architecture, modern data architecture, could look like on AWS. We also said that it consists out of 4 pillars, which is storage, S3 on AWS, purpose-built services for querying on consuming data from the data lake. We said that we need seamless data movement on AWS, that would be AWS Glue, between the services. And we said that we need data governance, AWS Lake Formation on AWS. And then we looked at the SaaS provider's lens and how that data isolation looks on for SaaS. We actually were talking about silo model or account per tenant. We talked about bridge model, and we showed the two options for bridge. One is prefix per tenant, and the other one is bucket per tenant. And we then talk about pool model and how AWS Lake Formation can help us to deliver row level security or even cell level security. That's it from me. I hope you enjoyed this session. Thanks a lot. And if you have any question, feel free to contact me. Thanks.